All right. So let's look at what's called function notation. Function notation. And what function notation allows us to do, we rewrite the way a function looks, and what it allows us to do is to condense our writing a little bit, and it lets us be a little more dynamic. And I'll kind of show you why here in a second. So let's write this. Say we have a function y equals x plus 2. Then, to use function notation, we write. So it's still going to represent the same thing. It just allows us to condense and clarify a few things. So if we have this function, then we can rewrite it to make our lives easier down the line. So we take this y and we replace it with f of x, and everything else is the same. All right. So that's what function notation is. It means y is equal to f of x. They're interchangeable. They mean the same things. All right. So from now on, we'll be using f of x. We could use g of x. The f is just there. It can be any letter. The f is just typically what's used. But I could have wrote g of x or h of x or b of x. I could write anything I wanted there. So just know that the f isn't a set letter to use there. All right. The way it comes in handy is you can write. Say I wanted to know what my y value is here if I input an x value of 1. So then I would say f of 1. This means that I'm inputting 1 into this equation everywhere there's an x, or this function, excuse me. So now I replace this x with a 1, and I replace every x in here with a 1. So now this x becomes 1 plus 2, which is 3. All right, if I wanted to know f of 5, that means I'm plugging 5 into this f function up here, everywhere there's an x. So this x became a 5, so every x in here becomes a 5 also. So this 5 plus 2 is equal to 7. So that's what makes it a shorthand. Let me show you exactly why. So say I wasn't using function notation, I was just using this. So we'll do this without function notation. All right. We'd have to write this to really explain what we're doing. We would have to say for x equals 0, then y equal x plus 2 is equal to. So this means we're putting, if x is 0, we're going to replace this x with 0 also. So it's 0 plus 2, which is 2. All right, so there's a bit of writing doing it that way. And let's say, and now I'm going to write this same exact thing in function notation. So with function notation, I did not spell that right. All right. I'm going to use the same setup, x equals 0. So let's do it. So I'm saying f of 0. So that's how I would write it. And then I'm just plugging in 0 in here for my x, just as we've done previously. That's equal to 0 plus 2, which is 2. So function notation allows us to not write this whole thing and to just write that shorthand. Over here, we had to write out specifically that for x equals 0, then we have this function is equal to 2. So it shortens by half. Here we had to write the for x equals 0 portion, then this. But over here, all we have to write is f of 0. This is telling me my x value is what's inside of these parentheses, 0. So it's saying my function f, remember we're going to be using different labeling later too, so it also tells us which function to use. So it tells me my function labeled as f, I'm using the x value of 0, and then I plug it in. So that's one of the good uses of function notation. All right. And so it is a little funky if you haven't seen it before, especially when you try to plug in numbers to these things. So let's look at a couple examples. Example 1, evaluate the following using f of x equals 3x minus 5 and g of x equals 2x squared minus 7x. All right, so we're given two different functions here. We're given f function, f, which is 3x minus 5, and we're given a g function, which is this thing here. So we're going to have to be able to delineate between the two when we answer these questions here. So let's find f of 1. What is f of 1 telling me? Answer that yourself. What is f of 1 telling you? Just based off what I've told you already. The f is telling you which function to use over there. F is saying to use this f function here, this one. All right? And then this 1 is telling you that your x value is 1. That's the number I want to plug into the f function. So use the f function and plug 1 into it. So everywhere there's an x over here, I plug in a 1. All right? So it would be f of 1 is equal to 3 times 1 minus 5. And if it helps, for the first couple examples, you can write the function you're using above it. But I wouldn't get in the habit of using that as a crutch, just to get your bearings about you and get going. So I replace this 1, I put a 1 in here everywhere there's an x. So it's 3, that stays the same, and then x, that x becomes 1, and then minus 5, which is equal to 3 times 1 is 3, minus 5, and that equals negative 2. All right, try this one. Try f of 5. All right, pause the video and try it. So f of 5, what is that telling me? That's telling me to use the f function and to plug 5 in there for x, x. So here's my f function, and I'm going to plug in 5 everywhere there's an x. So f of 5 is equal to 3 times 5 minus 5. So f of 5 is equal to 3 times x, the x here is 5, and then minus 5. This is equal to 15 minus 5, which is equal to 10. All right, give this next one a try yourself. We'll call it part C. G of 2. Pause the video and give it a try. All right, G of 2, it's telling me what function to use, G, and what to plug in it to. So I'll come over here and I'm going to use this function, G, and everywhere there's an x, I'm replacing it with a 2 now. So G of 2 is equal to 2 times x squared, that x is a 2 now, minus 7 times x, and that x is a 2 now also. Again, if it helps, you can write above it the function you're using, just to help out in the beginning here. So G of 2 means you get 2 times x that x is 2 now. And then that 2 is squared. Minus 7 times x, but that x is 2 now. A lot of 2's in there, and that is my fault. But that's all right. So 2 squared is 4. 2 times 4 is what we get out of that. Minus 14. Then 8 minus 14. And that's negative 6. What do we get with this? Try f of a. Try it yourself, pause the video and come back. So here, we know we're using the f function, and it's telling me my x value is a. That's weird. Alright? I can plug anything I want into these functions, and so here it's just going to be a. So I know I'm using the f function, and I'm plugging a everywhere in that function where there's an x. So I get f of a is equal to 3 times a minus 5. So this is 3a minus 5. All right, let's try two more here. E, try f of a plus h. So now I'm just adding something else inside of those parentheses, and now I'm making what's inside, what you need to plug in, even longer. But it still works exactly the same. You just read it as, what function am I using? F. What am I plugging in? A plus h. So you're using the f function, and you're plugging in a plus h everywhere there's an x. And if you need to write the function above it, then go ahead and give that a whirl. So f of x, so I have f of a plus h, and everywhere there's an x over here, I'm plugging in a plus h. So I get 3 times a plus h minus 5. So it's 3, and you have to be careful here. You have to open a parenthesis. A plus h minus 5. Because you're going to have to distribute that 3 in eventually. All right? I want to look at one more. And let's just try f g of a plus h. Give that one a try by yourself. So it's telling me to use the g function and to plug in a plus h for my x values. So I get, if I wanted to write it above it, I get this. And that's equal to 2x squared minus 7x. If you want to write it above what you're doing, so that way you know where to plug in the x's, do that until you get the hang of it. So this 2 stays here. This x becomes a plus h now. And then it's that whole thing squared. You have to make sure you keep those parentheses and you keep the squared, you keep whatever's there. And then this minus 7x. X is a plus h though. And again, parentheses. Now the reason I'm showing these now is because later on you're going to get into an instance where you need to know how to do these and combine them. And we'll, at that time, we'll get into how to simplify this because it can get messy. And I'm not going to worry about that at this moment.